This is lecture 23 example 2. This is going to be a programming example. Fairly similar to ones we've done before. A little bit of new stuff in there. And so let's do it. And so this is a subroutine that is going to go to memory, look at words in memory. Those words in memory are Stone Age unary numbers. And what I want to find is the largest Stone Age unary number in memory. Now this is a example that gets sort of long, and so we're not going to be storing context anywhere in here. We do need. I'm going to do something a little bit different just to make it simpler. Essentially, I'm going to make a nested subroutine in there, which is going to cause us to need to store the return address on the stack, and that's something usually I do last, particularly when I'm working on typing it in on an editor. So anyway, so it goes to memory, looks at words in memory. The words are stored as Stone Age unary. It finds the largest one. The number of words to check is in x20. I'm going to store the result in x25. And so that's a good start in this thing. We're going to go ahead and do a flow chart on this thing. And for the first thing is we're going to do a Stone Age unary to binary conversion. So I'm going to call this calc unary. This is going to be a subroutine, and when I do this, I'm going to have to init some stuff, which is typically a count, and then I'm going to say, am I done? And if I am, I'm going to say return. I'm kind of trying to stuff it in here, keep it small. Okay, so if I'm not done, I'm going to do a couple things. We've seen this before. And one is I'm going to mask the LSB, and then I'm going to accumulate that in some register, and then I'm going to do some loop admin on this. And then I am going to go back to this loop here. Okay, so that's going to be our unary to binary conversion, and looks good. Okay, so what we're really interested in here is the entire subroutine. We'll call it big unary. Great name. Okay, and so typically I need to init some stuff, which is typically going to be the value. And what I'm going to do here, we've seen this algorithm before, is I'm looking for the biggest thing, and I'm going to keep the algorithm very generic. So I'm going to start out saying 0 is my biggest thing, and every number that I find that's bigger than 0, that's the ones I'm going to store. So I'm going to go ahead and do this, and it's going to be a while loop. If there's count equals 0, I'm going to say yes, it returns. Okay, no is the interesting thing. So I'm going to get data. This is going to be getting data from memory. I am going to, after I get the data, I'm going to call calc unary. Whatever, ran out of space there. Then I'm going to say, is this big? And this will be no. And I have to do some admin there. And if it is bigger, I am going to have to, I'll say set new big val. And then come back here, looking good. And at that point, I'm going to call myself done. Okay, so this is going to be nested subroutines, and so I know I'm going to have to. I'm going to have to save the return address sometime before I get to call that second subroutine. Now, the idea is I'm not going to save it down there. I'm going to save it before I get into this loop. So typically, it's going to be part of my initialization at the top of the program. Like I said, I always save that for last, just to keep the program uncluttered. So whatever. Okay, so I'm gonna copy this and bring it over into Venus so you can see it a little bit better, and then type it online. Okay, so this solution is in the text somewhere. It's at the end of the problems, because end of the chapter for, I think, 15 problems, because I just added it. Okay, so here we are over the Venus land, using Venus because I'm not doing anything with interrupts, so it makes it come out really nicely. And so what I need to do is implement these two flowcharts over here. So I'm going to start with the subroutine, which is the calc unary. So I'm going to call it calc. You gotta hang with me on this one because I got a new keyboard because the other keyboard died. And so this is going to be the unary to binary conversion. So I need to start it off with something like a putting a sum count. I'm just going to call it x31. Sum count as 0. So this is the new count. So this is going to be binary count, and then I'm going to model this as a while loop, and I'm going to send it a value which is arbitrary. So I'm just going to say x30. So I'm going to say BEQ x30 x0 done. Let's see if 0. Okay, I'm going to move these over. I like having space here. Once again, I'm at this point right here in the initialization part of it, and now I'm jumping to this, which is going to be, obviously it's a while loop, and I like getting rid of the red mark here. Done. Okay, there we go. Okay, and so if so if it's already 0, there's nothing more to count, and the count's going to be in x31, and I'm going to be done. But if there is a count, I'm going to mask it. So there's the mask LSB, mask, and the return, let's see, let's get this right, end immediate. The value I'm interested in is x30, and this is going to be not x30. Got to put it somewhere else, so we have to protect it, x30. And then I am going to end immediate with 1. So this is going to be mask LSB. Okay, so that's going to mask LSB. I have the LSB in x29, so I'm going to add that. Immediate, is it immediate? Nope, x31. x31, I'm going to accumulate that in my count register. Accumulate. Okay, so that's this box here, and then the admin, just typical loop admin. For this, it's going to be a shift right logical immediate x. Let's see, what are we doing? x30, 30, x30. Shift it right once. Shift right, and then I'm going to jump to loop and say do again. You've seen this before. We've solved these problems before, and this is going to be a return. I think I'm going to run out of space here. Let's do 30. Okay, and I think that's done. I don't think I need to do anything else on this one. So once again, I kind of crammed it in there because I know this is going to require extra space. And so that's this this left flow chart here. And now I want to do the other one, which is the big unary. Okay, and there's always going to be initialization stuff. And so for the init, okay, so I already got a problem there. We'll call this init 1. I already used the init label, and the program itself has, I wrote it down somewhere. The value, the large value I'm going to return is an x25. So first thing I'm going to do here is move or load immediate. nope, load, move x25, x0. So I'm starting it off at 0. I'm going to say start large at 0. Okay, this is a generic algorithm. I'm saying the largest value is 0, which, I mean, if every value in memory was 0, I don't lose anything on this. It's still going to return the right value. So I'm starting off at 0. I could do this other ways, but this keeps the algorithm very generic and the code short. Okay, so at that point, I also have a count in here, and so I'm going to model this like a while loop like we did before. So that's this thing here, and the count is in x20. So I'm gonna BEQ x20 x20 x0 to, at that point, what am I going to do? Am I just done? Done. And it's kind of not like that, so go to n. Pretty exciting. Okay, so that means if I'm done, I quit. Let's get this red line out of there. Okay, there's my done. And I got some issues with done, so I'll fix those later. So if I'm not done, here I am. I'm going to get data, so that's load word. I need to load it somewhere intelligent. It really doesn't matter. It actually does matter where I load it because it expects it to be, the subroutine down here expects it to be an x30. So this is x30, 0, x, wait, address here, 10. Got to remember it from the problem. So this is going to be get data. Okay, after I get data, I'm going to call my calc-unary. Call calc unary. That's going to do conversion. Okay, after that, my value is going to be an x31. And so that's what I need. This is, like I said, this subroutine down here puts the binary equivalent of the Stone Age unary in x31, so that's what I'm going to compare. So what I'm interested in doing is, if this value is less than or equal to, I don't want to do anything. If the value that comes back in x31 is greater, that's when I want to do something. So I'm going to say, check my cheat sheet here. I have B. But there's probably a branch if less than or equal. And okay, there is BLE X X third less than or equal X31. Get this right. X31, X25. So X31 is the new value. If it's less than or equal to X25, I'm going to do nothing. Admin. I'm going to do some admin. Okay, so looks good. Here's my admin label. I'm going to make this beautiful. Okay, so that's this one. If it's big, jumping over here. Otherwise, I need to set a new big value, which means swapping the values in x31 and x25. So I'm going to say move x31 to x25, so it's backwards, x31 to x25, 31. I'll say set new large value, and then I guess I'm done. I'm at the admin at that point. Okay, and there's my admin label. I think I'm going to, for space considerations, I'm going to delete that out of there. So the admin, I need to do two administrative tasks, which is to advance the address, add, and that's an x10, x10. It's dealing with words, advance it by 4. Okay, so that's it. We're in this box here, and then I also need to decrement that count. ADDI count was in x20, 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 and this is count. And then I'm going to jump, loop, and I know I need to do it right. Check again. Okay, and then this is going to be my loop right here. So what we're doing is jumping back from here to there. Okay, and this is going to be loop 1. I think that's looking good, and I'm going to say return, and I know it's not right, but I'm not going to put it there. I'm going to say all done. And the reason I'm not going to do that is because it's a nested subroutine here, and so I need to protect that. I need to protect the return address, and I need to push it on the stack. I need to do it outside the loop, so this is going to be add immediate sp -4, make space, and this is going to be store word RA. I forgot. I think it's x1 RA. No, I know I can write RA 0 SP. I'll say push RA, and okay, there's the push, and the return is here, which is load word at RA as 0 SP. Essentially, I'm just undoing the top push. So this is a pop RA, and then I have to adjust the stack pointer, which is SP. No, it's 4. It's opposite of -4, which is 4. Okay, I think I'm done. I think I'm done. So let's run this thing, and I'm actually gonna test it. Okay, so if it goes over there, okay, loop. I got a wanky label in there somewhere. So loop is dead. Loop is this one. I don't have the loop. So this is my loop. Try it again. Okay, looking good. And I'm going to put some junk test data in here. So this is going to be, see if I can see if this works. Data. This is my data segment. Junk. I'll make a label there. I'm going to make some word data. And I'm going to say 0x. Let's do something easy. It's finding the largest, so we'll say 3. 0x7. So this should come back with the value of 3. Because there's 3 set bits in 7. Okay, there's that one, and then I need the text segment, which is going to be load address. Remember, this is test code. Load address x10 junk. There's the address of junk. I have 2 values. Load immediate x20, which is 2, and I think I'm ready to test this thing. Okay, so hopefully we're kind of off the page here, but sorry about that. See if I can fit that back on. Whoops, I'm having trouble fitting it back on. Well, good enough. Good enough. It's the solution's in the book. So let's go ahead and simulate this. So with any luck, when I'm done, x25 will have a 3 in it. So let's go look at this. Let's go look at the simulator on this one. And I think I can expand this over. Okay, that's good. We'll lose our flow chart. But step through it. We'll look at, what are we looking at? X25, right? Hopefully this works. This is the value we're looking at. Hopefully by the time we're done, this will be a 3 in it. And if it is, we're just going to call it done. X25. There's the 2 from the, that's from the 0x3. Let's see if it replaces X25 with a 3. And it has some problem here. I think it jumped in the wrong spot. How about decrementing the loop count by 1 rather than 2? All right, let's try that again. Okay, so we're interested in x25. It should come up 3 at some point. There's the 2 from the 0x3, and there hopefully there's the 3. Looking good. Blah blah blah. Pop, 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 and we're done. Okay, so we're going to call that done. And so this is our program here. Once again, something very similar is going to be in the book, or you can look at this program here. The test code is up top. Actually, you can see all the code right there. Okay.